Dear students, today we are discussing the third property of arithmetic mean. Let us consider a series of observations, and each series uh, is having a mean xi bar. Okay, mean of the composite series. So we have to find out the mean of the combined series. Let us consider uh, uh, the mean of uh, k number of series. That is, first series is having mean x1 bar, second series is having uh, mean x2 bar, etc., xk bar. I will show you an example. And so we have to find out the combined uh, mean of the series. For example, let us this column represent uh, first series observations. Okay, and the column B represent another set of observations, and the number of observations in each series need not be equal. So here we are considering three series of observations. Suppose this series is having total 18 and a mean equal to 18 by 6. Total and mean. And this set of observation has total 37, mean equal to 37 by 8. So what is the total and mean? 37 and 4. This series has total 13 and mean equal to 13 by 4. So here we have three series of observations, and each is having mean 3. First series has mean 3, second series has mean 4.625, third series is having mean 3.25. So like this we can find out uh, the mean of each series. Here we are considering k number of series. Okay, and the number of observations in each series is denoted by n1. So in our example, n1 equal to, in this case, n1 equal to, what is that, 6. In this case, n2 equal to how many observations? 8. In this case, n3 equal to 4. Okay, so there are n I number of observations in each series. Then mean of the composite series. Mean of the composite series is obtained by combining the component series using this formula. Okay, that means suppose we want to find out the mean of this all observations, combined series. So what is the combined series? Yeah, you can take this observation. Okay, let's put here. Okay, you can take this observation. We're combining the observation. Okay, put here, and you can take this observation and put here. What is the mean of the combined series? Yeah, take the total of this series. What is the total? 68. What will be the mean? 68 by how many? 18 observations. Okay, so the combined series has the observation, a mean 3.77. So we can find out this 3.77 using this corresponding means. We can take, what is that, 3 into 6 into 3, that is 18. You can put this value 18 plus this value, total, that means 4.625 into 8 plus take the sum. Okay, enter. Then after that you can divide with the total number, divided by 6 plus 8, that is 14. 14 plus 4, 18. Okay. Right? These two values are same. Okay. These two values are same. So what are the method we have used? We have combined this mean and taken the total and divided by total number. So instead we can compute the mean of each observation, and we can add the total of each observation. Okay. Uh, what is the formula we have used? Yeah. N1 x1 bar. X1 bar. Can we represent that formula? Yeah, let us take the word format. We can represent that mean. So what will be the formula? Yeah, what is the formula? Okay, mean x bar equal to we can take the, what is that, n1 x1 bar plus n2 x2 bar plus n3 x3 bar. You are clear with this this formulation? Okay, this is divided by n1 plus n2 plus n3. Okay, so we have obtained using we have obtained the combined mean using this formula. So what is this value? In our example, this is nothing but, is n1 is 6. 6 into 6 into 6 sorry, 6 into, what is x1 bar? 18, not 18, 3 plus another set has 8 into 4.625 plus next is 13 sorry 13 not 4 into 3.25 divided by, what is the total number? 6 plus 8 plus 4. So this is the value we have obtained when we compute this. This is nothing but 3.777778. Okay, so that is actually the combined mean that we have obtained the combined mean in a different way. So this is the formula for obtaining the combined mean using the series means. Okay, n1 x1 bar plus n2 x2 bar plus etc. nk x bar divided by n1 plus n2 plus etc. nk. Okay, so this is a short form of the formula. Summation over I ni xi bar divided by summation ni. So we have to prove that. Let x1 x1 to x1 to x1 n1 be the n1 number of observations on the series. That means these are the x values. This is x1, x2, etc. x n1. Okay. Now we have, similarly we have another set of observation. This is x1. This is x1, x2, etc. Similarly, we have another set of observation. This is x11, 1, 2, etc. 1 and 1. Okay. So these are the observations. I think you can you are clear with this notation. And here also we can represent some x21, x22, etc. How many? Yeah, x2 and 2. Okay, in general these are the another set of observations. Okay, okay, and here also we have another set of observation. So this is x31, x32, etc., x3 and 3. So that is the notation for the observations of this each series. Okay, x11, x12, xn1, and are the members of n1 members of the first series. x21, x22, x2 and 2 are the n2 members of the second series, so on, and xk1, xk2, xk and k is the nk number of observations in the case series. Okay, so we can find out the mean of each and every series. Yeah, this is the mean of x1 bar, x2 bar, etc. xn bar. What is x1 bar? Take the sum of that observations in that series divided by total number. x1 plus x1 2 plus etc. xn1 divided by n1. Similarly, x2 bar equal to x21, x21 plus x22 plus x2 n2 divided by n2. And likewise, we can find out a mean of each series. Okay. So then, as we have represented in this column, first of all we have what is that? We have taken the first set of observation. Then we have taken the second set of observations. Okay, and at last we have taken the third set of observations. Okay, okay, so that representation is given here. First set of total of first set of observation, then total of second set of observation plus total of last set of observation divided by total number n1 plus n2 plus etc. nk. So but this can be represented as, because using this formula, what is that? Yeah, we can move this n1 to left side. So what will be the sum? Yeah, instead of this sum we can represent just n1 x1 bar. Okay, similarly, instead of this sum we can represent by moving n2 to x2 bar, we can represent as n2 x2 bar plus etc. For the last term, instead of this one we can move this nk to this side and we will get nk xk bar divided by total number n1 plus n2 plus etc. nk. So this is the formula for obtaining combined mean of observations. I think you got the idea, and it is sometimes very easy to find out the combined mean using the this. If we have, suppose the problem in a problem it is given that x1 bar is given, x2 bar is given, etc. xn bar. Instead of giving the observation exactly, the problem can be expressed in terms of what is the mean of each series. So in such cases we can use this formula. So that is the idea. For example, the example is given below. The average salary of male employees in a firm was 520. So in this problem there is no observations. The observation is only the mean of the male employees. Okay, so there is no observation like the salary of person 1, salary of person 2, etc. So they have given only the mean of the salary of male people, and similarly mean of the salary of female people is given. There is no observation here, just giving the mean. So the company may be interested to find out the average salary of a pupil working in that company. Okay, so the mean salary of all the employees was 500. Okay, the problem is very interesting. It is given that x bar is given, mean salary of all the employees was given. Okay, that is rupees 500. Find the percentage of male and female employees. So to find out the percentage of male and female employees, we have to find out N1 and N2. Here we have only two series, male series and female series. It is given that, so as in this problem, it is given that given that x1 bar is given. What is the value? What is the value? X1 bar value 520. 520. Okay, 520 is given. Then another value 420. Okay, 420 is given. 420 is given. Okay. Moreover, the total combined mean is also given 500. So in this formula, so what we have to find out? We have to find out N1 and N2. Then only we can find out the percentage. Okay. So we can move this. What is that? Yeah, it is represented like this. We can move that. Yeah, it is represented in this. Okay, we can move this move that N1 plus N2 to left side. That is 500 into 500 into what is that? N1 plus N2 equal to 500 into N1 plus 520 into N1 plus 420 into N2. Okay, to N2. So we can simplify. We can move N1 terms to left side and N2 terms to right side. So there is only N1 term. Along with N1, left side we have 500 and in the right side we have 520. So 520 minus 500 N1 equal to 500 minus 420 N2. That is 20 N1 equal to 80 N2. That is N1 by N2 is equal to 80 by 20. That means 4 by 1. 4 is to 1. So the percentage of how can we find out the percentage? Yeah, N1 is 4 times bigger than N2. Okay, N1 by N2 is 4, means N1 is 4 times bigger than N2. So what is the percentage? Yeah, this is 4 by 4 plus 1 into 100, that is 80. So 80 is 4 times bigger than 20. Okay, multiple of 4. 20 is the what is that percentage of female employees. 1 by 4 plus 1 into 100, that is 20. So this is an interesting problem. So look at this problem, that in this problem there is no observations are given. Okay, it is given only the mean of each and every series. Okay, so that is the beauty of this problem. So similarly we can find out what is that, in the case of several series. Okay, that is the general formula is given. Sometimes the problem will be to find out the mean of the combined mean, or sometimes the problem may be to find out the percentage N1, N2, etc. So what are be the quantities? Sometimes, so here we have X bar, N1, X1 bar, N2, X2 bar. So there are 5 terms. So among these 5 terms, we may have to find out any one of the 10. The problem will be like that. In this problem, it is we have to find out that the N1 and N2. In some other problem, we may have to find out the combined mean. So that will be depend upon the nature of the or requirement of the problem. Okay, so you can try read and write and try to understand this problem. Okay, similar problem will be appear in the examination too. Okay, so there are merits and demerits of arithmetic. When we study several measures of central tendency, we are studying several measures of central tendency, especially mean, median, mode. In mean, we have 3 type of mean, that is arithmetic mean, geometric mean and harmonic mean. So what measure or what type of measure we have to use in our problem? So that depends upon the requirement or merits and demerits. Okay, so what are the merits of arithmetic mean? So we have to understand the merits and demerits of arithmetic. After that, after understanding this type of merits and demerits or requirements, we have to apply the proper measure. Then only we can apply the proper measure to the particular problem. Okay. we cannot apply every measure to every problem. We have to apply a measure to a problem based on the requirement or based on the nature or based on the merits. Okay, so we have to understand the merits and demerits of a each and every what is a central tendency. So first of all, we are considering merits and demerits of arithmetic because we have already studied. What are the merits? One is it is rigidly defined. Clear cut mathematical formulas are given there. Okay. Second one is it is easy to understand, easy to calculate. Very simple. Okay. In this problem, in all these problems, we are using simple mathematical addition, multiplication, division, etc. Techniques. So it is very easy to calculate. It is based upon all observations. So we are considering all the observations. So look at this formula. Okay. When we look at this formula, we can see that all observations are taken account for computation of the mean. Okay. So it is amenable to algebraic treatment, mathematical treatment. The mean of composite is in terms of mean size of the components is given by, that is we have discussed now. Of the all averages, arithmetic mean is affected least by fluctuations of the sampling. This property sometimes described saying the arithmetic mean is stable average because what is that? It is less affected by sampling, methodology of sampling. So that will be discussed in future classes. Okay. So what are the demerits? We have to understand the demerits too. Okay. It cannot be determined by inspection nor it can be located graphically. We cannot what is that, locate by graphically. Not to locate it by graphically, we have to we should have some xy component. So there is no xy, only one component is there. The remaining discipline. Arithmetic mean cannot be used if we are dealing with qualitative characteristics which cannot be measured quantitatively, such as intelligence. Sometimes we cannot measure intelligence. How can we measure intelligence? Or honesty, beauty? How can we measure the beauty? The criteria for beauty or intelligence will be different for different countries or different for different companies. Okay, if you are a mathematical student or mathematics students, we cannot measure your intelligence based on your mark, because for a zoology student or chemistry students, their interest may be in chemistry or what is that, zoology, but they may not have enough mathematical ability, so we cannot say that he is not having or she is not having intelligence. Okay, so we cannot measure the intelligence like kilogram, gram, centimeter, meter, or degrees Celsius, etc. So that is a quantitative quantity. It's good. Qualitative means it is good, better, best, etc. That type of characters we cannot measure that type of characters: intelligence, honesty, beauty, etc. So at the same time, we can rank that observations. Okay, we can rank. This is highest. This is highest or based on some what is it, from non-mathematical criterias. Okay. So in such cases, we will use the median. Uh, Another disadvantage: arithmetic mean cannot be obtained if a single observation is missing or lost, or if it is illegible unless we drop it out and compute the arithmetic mean of the remaining value. Suppose we are suppose there is one observation is missing. So suppose suppose that we don't have this observation. At the same time, we are considering that position. So if we don't have this observation, value of this observation, we cannot find out the mean. So we have to remove this, and using the remaining observation, we can find out the arithmetic mean. Okay, so that makes problems sometimes. Arithmetic mean is affected by much by extreme values. In the case of extreme items, arithmetic mean gives distorted picture of the distribution and no longer remains representative distribution. So it's very dangerous problem. Okay, I will show you. Suppose these observations are in between 1 and 10. Okay, suppose some observations are repeated, some observation like this. Okay, I will copy this and actual observation, and suppose that there are some extreme observations. For example, it is 200. Okay, it is what is the mean of this observation? 3.71. So that lies between 1 and 1 less than this less than, and all these observations are lies between 1 and 10. So we can use this mean as a representative measure of this distribution. Okay, this data. Suppose two observations are what is that, are like this, 200 and 500. What will be the mean? Let us take the sum. Okay, this is a sum. Let us take the mean. How many observations? There are 18 observations. Yeah, 42. So you know that this is observations lies between 1 and 10. And since there are two observations, two extreme observations, the mean looks like this. Okay, 42. Will it be a representative part? Will it be a representative measure? No. Why? All the observations, most of the observations are in between 1 and 10. But the mean is 42. That is, that cannot be, what is that? It is not meaningful. Okay. What will be the behavior of mean? I think you might have seen the galaxy. Okay. I have shown you that the nature of the galaxy. So what is the position of the central value in galaxy? Okay, look at this. I will show you, no problem. So so if there are extreme observations, we cannot use mean. Okay, we cannot use mean. So we have to avoid that mean. Instead, we have to use any other measure. Okay, so that is the one of the disadvantage of. So look at this figure. Okay, the mean is some central value. Okay, mean should not be like this. Mean should be somewhere in between the observations. Okay, this yellow part is not the central value. This is the central value. This is exactly central value. So if there are extreme observations, we will have mean outside the common region. Okay, so we have to we cannot use the mean for that type of observation involving extreme observations. Okay, that is explained here. Another disadvantage is arithmetic mean may lead to wrong conclusions if the details of the data from which it is computed are not given. Let us consider the following marks obtained by two students A and B in three sets: terminal test, half yearly examination, and an annual examination. So first test, they have obtained the mark 50 and 70, second is 60 and 60, third is 70 and 50. Average mark is 60. Okay. So average mark obtained in this examination for these two students are 60. Okay. If we are given the average mark alone, if we are given the mean alone, we conclude that the level of intelligence of both the students at the end of the year is same. Okay, if you have 60% and another student have 60%, you can get almost what is the intelligence level of the intelligence will be almost equal. Okay, but at the same time, look at this exact observations. What is that? Yeah, one student, the nature of one student, 50 to 60, 60 to 70. That means he has what is improved much by studying during a semester duration. Okay, so at the same day, the second student, what is the behavior of second student? Yeah, his mark is going down. What happens? He's not improving. So who will be having more intelligence? What conclusion we can take? So we have to take what is that? The first student A. is more intelligent than the second student B. At the same time, their average mark is 60 and 60. So when we judge based on these average values, it will lead wrong conclusions. Okay. If we see only the average mark, what can we say? That both students are equally intelligent. At the same time, if we see the observations, we can say that the first student is improving much. At the same time, second student is not improving, if he is getting down. Okay. So that type of, if we want to say that type of informations, we have to see the observations. So arithmetic mean may lead to wrong conclusions sometimes. Okay. I know that I have joined the Indian Statistical Institute at Kolkata in 2006 for the PhD. So and for that selection, uh, I had to uh, appear an interview. I had to appear for a test, and they will look at the mark obtained during SSLC. They will look at the mark attained during plus two. They will look at the mark attained during the degree course, PG course, and then only if the student is found to be improving much, then only they will select. So I got selected in Indian Statistical Institute in 2016, and I joined at Indian in Kolkata there. That is based on the history of my what is that, education. Okay, in my history, I will show you that. Yeah, yeah, JRF in Indian Statistics. No. Okay. Okay. Anyway, I am just I want to just show you my experience only. Okay, I have joined there based on my academic record. So they have looked in the academic record I have obtained you in SSLC plus two degree PG etc. And at last they will make a test, entrance test, and after that they will conduct an interview. So these 5 steps have already completed for the selection. Okay. So I I shown these marks only because the based on this mean, arithmetic mean, we cannot ensure the students are equally intelligent. So sometimes wrong conclusions may be what is that, defined based on the this type of central tendencies. So that will lead what is that, wrong decision, and that will lead what is that, um, uh, what is that, falsy decisions. Okay, so that is a disadvantage. We are discussing the demerits, merits and demerits. So that is the disadvantages of arithmetic mean. Okay, you can read all these terms. Now another disadvantage: arithmetic mean cannot be calculated if the extreme class is open. So sometimes we are getting the in the case of class frequency data, sometimes it will be open. So in that case, we cannot compute the arithmetic mean. Okay. Uh, in extremely asymmetrical distribution, usually arithmetic mean is not suitable for measure of location. So arithmetic mean is exactly measure of location. Hmm? So I will show you some symmetric and asymmetrical distribution. Okay, look at this asymmetrical distribution. Here, in this symmetrical distribution, mean and median same. At the same time, for an asymmetrical distribution, mean, median, and mode are different. So mean may not be a representative measure for the central tendency in the case of asymmetrical distribution. Okay, so we have it. So but in the case of a symmetrical distribution, we can use the mean as a what is that, measure of central tendency, or we can use this mean as a measure of central tendency. So that is the, so when we have asymmetrical distribution, that means skewed distribution, we cannot use arithmetic mean as a measure of location. Okay, so up to this you can write and submit in the Moodle platform, no problem. And we will discuss the remaining time in the next class. Okay, you can look at the symmetrical and symmetrical distribution. Okay, what is the difference? Yeah, there are plenty of distributions available. Hmm? Yeah, this is skewed distribution, positive skew, negative skew. So in this case, we cannot use mean as a proper measure of central tendency. For the symmetrical distribution, it is a proper. Okay, mean and median and mode are equal. Okay, so you read and write and submit in the Moodle platform. And if you have any doubt, you can ask to me, no problem, when we come in live. Okay.